I'd like to review the rock falling for 3 seconds problem that was given to you as part of the reading. Okay, so let's go through our 5-step process. Okay, 1, we're going to draw a picture. We have a high bridge with a rock falling. 2, what are we being asked to find? We want to find the velocity after 3 seconds, so we're finding a final velocity. Okay, and maybe at 3 seconds. 3, what is it that we know? Or what are we given? So our givens. 1, it's dropped, so we know that the initial velocity is equal to 0. Okay. We also know that the acceleration due to gravity, this is on Earth, so we know the acceleration is 9.8 meters per second squared, or meters per second. Okay. We also know that the time is 3 seconds. And just a note on the givens, the acceleration due to gravity is used so frequently that it has its own name, and we just end up putting the value g for acceleration due to gravity. All right, number 4 is our relationships. And we're looking for a relationship that will relate our acceleration, our final velocity, our initial velocity, and our time. Let's take a look at this one. That our acceleration is our change in velocity, also known as our final velocity minus our initial velocity, divided by time. And number 5, let's go ahead and solve this. I do have my acceleration, I have a time, and I have my initial velocity. The one thing I'm looking for is that final velocity. We could rearrange this, and I'm going to do this in the classic physics way, where I end up isolating the variable. Many people feel more comfortable about inserting numbers in kind of early, and I'll do that as well. So if I have acceleration is equal to final velocity minus initial velocity over time, multiply each side by time. Okay. And I realize that initial velocity is equal to 0 because I'm dropping this. I get acceleration times time is equal to my final velocity. Acceleration, in this case g, for gravity 9.8 meters per second times my 3 seconds gives me a final velocity of 29.4 meters per second. Okay. Just briefly, we can end up putting this together a different way. We put the numbers in a little bit earlier. So now I put the numbers in earlier, just another way of solving it. 9.8 meters per second is equal to my final velocity minus 0 divided by 3 seconds. That goes away. I multiply each side by 3 seconds, and I get the same value. 29.4 meters per second is my final velocity after 3 seconds. So we're going to take a look at part number 2, and that is how far did it fall during those 3 seconds. Okay, so I'm just going to move a little bit further down the page here. I'll keep that same drawing, and we'll go through the same exercise. So my second part of what am I trying to find? How far did the rock fall during those 3 seconds? Or another word is, hey, what is my delta x or my displacement? Okay, so 3, what am I given? So I'm given that the time is 3 seconds. Acceleration, I'll talk about that in just a moment. My initial velocity, I dropped it, was 0 meters per second. The final velocity after 3 seconds is 29.4 meters per second. We know the acceleration is 9.8 meters per second, and again, we can call that g if we'd like to. Okay, let's go ahead and we'll take a look at relationships. We're going to solve this 2 different ways. Hey, the first relationship we're going to look at is, hey, we know that displacement, or we can call that d, or delta x, is equal to velocity times time. Now that works out fine if our velocity stays the same. If we have a varying velocity, then we end up saying it's equal to the average velocity times time. Okay, let's take a look at that. Hey, so my displacement is what I'm looking for, and I'm given time, but I don't have an average velocity. Let's look for another way of expressing that. Hey, so I know my average velocity is equal to my initial velocity plus my final velocity divided by 2. The average of two the average of two numbers. Okay, now we have everything we need to solve that, so let's go ahead and solve. So my displacement is my initial velocity plus my final velocity divided by 2, because I could replace that for my average velocity, and I know all those, times time. Let's go ahead and put all those numbers in place. So we have 0 meters per second, our initial velocity, plus 29.4 meters per second, our final velocity, divided by 2 to get the average, times 3 seconds, and we get 44.1 meters. Now let's look at another way we can solve this given the information we have here. You may remember before that we know that acceleration times time is equal to our final velocity when our initial velocity is 0. Let's see if we can end up using that to our advantage. Okay, so we have the final velocity is equal to acceleration times time. We're talking about the special case where something is dropping, so we'll end up saying, instead of using A, we'll use G for gravity. Okay, so we see that displacement over here. Displacement is our initial velocity plus our final velocity divided by 2 times time. Okay, but we also have this relationship for final velocity, and we know that initial velocity is equal to 0. Let's go ahead and substitute those things. So we see our final velocity can be replaced by gravity times time. We see that here. Our initial velocity is 0, and we're dividing this value by 2 and multiplying it by t. So let's go and combine terms. We can see that our displacement is 1/2, this value here, g t times t, or t squared. And this is the equation that was given to you in the book as another way of figuring out how far we've fallen. Let's go ahead and plug in numbers and see if we get the same value. So I'll take 3 seconds squared. That's going to be 9 seconds squared times 9.8 meters per second squared times 1/2. I get 44.1 meters. The same value I got over here. So both are equivalent. I can take the average velocity divided by 2 times my time if I'm starting from rest, or I can take that my displacement is equal to 1/2 acceleration due to gravity times time squared. See how that compares to the answers you got.